Hi, Math105. I'm Tyler, and for my final project, I delved into the Counting and Probability Project 1, where we look at French mathematicians such as Fermat and Pascal, and the work that they did with finding the probability of gambling at the time. So before delving into what they did with probability, just giving a brief background of our famous French mathematicians. Pierre de Fermat was one of the early 17th century mathematicians who actually studied law and served in local parliament in Toulouse, France at the time. Um, Oftentimes, he's called the founder of the modern theory of numbers and is credited with finding fundamental principles of analytic geometry. He also worked a lot with curves and the mathematics of curves, so finding the curve maximum, minimum, um, finding a lot of information that leads to integration, um, which further leads to the finding in what we know as our differential calculus in today with everything with integrals, stuff like that. All that can be credited to Pierre de Fermat. And as well, he is accredited as being one of the founders of probability of the time. Alongside Fermat, Blaise Pascal also is credited as being one of the founders of probability at the time. And he had quite a different upbringing where his father actually kind of dedicated his life to teaching his children, which resulted in him having extremely developed and advanced children. Blaise's sister Jacqueline Pascal actually was accredited as an infant prodigy with literacy and reading, everything kind of with the language in France, whereas Pascal took on more the math side. He was regarded as a physicist, a religious philosopher, and a master of prose, as well as being a mathematical genius. So he kind of had a lot going for him. Within his physics, he's really renowned for his principle of pressure. Finding kind of the science of contained spaces, and he did a lot of work with what we know of vacuums in modern day. Another figure at the time was the Chevalier de Marais, Antoine Gambeau, Chevalier in French meaning knight. So he was pretty high up and he spent quite amount of time actually gambling, which is kind of where he fits into this whole probability thing. You can kind of see in this image right here being presented with all these royal things and seems a little bored, but you can definitely see all the gambling tools, all the money, the wealth that he kind of had at the time. So basically, Chevalier de Marais, Antoine Gambeau, reached out to the mathematicians at the time about the math of gambling, finding the probability to win, making sure that things are fair. A lot of times he questioned things about if rules were changing, exactly how that affected his probability of potentially winning or losing his wealth through gambling. Luckily, sorry. Luckily, our one of our early scientists at the time, or scientists, mathematicians at the time, Fermat, also was bedridden, and the doctors told him to do stuff that was less mentally stimulating. At the time, they didn't really want him using his brain too much as they thought it would damage him further. So he kind of turned to gambling too. So they kind of found familiarity here, which made him a natural person for him to reach out to. When Fermat was reached out to, he communicated with our other early mathematician in France at the time, Pascal, and they kind of went back and forth in these letters about probability, arguing the logic of probability, and oftentimes finally coming to an agreement of what probability is, how it should be done, and such. So one of the problems that we kind of brought up by the knight of Marais at the time was, what if a game can't be completed and something is being waged? If there's money on the line and something happens where we can't finish the game, but there are enough results that lead us to be able to figure out what we should do with this money besides just giving it all back to whoever paid in. So our scenario in this would be a gambling game where the first player to win coin flips on a fair coin would win, whatever the wager is. Um, in this, I set up that Fermé and Pascal are playing for 100 francs, which was the currency in France at the time. Um, so when Fermé had 8 flips to Pascal's 7, the game must stop suddenly and would not be able to be resumed. So this kind of brought up the question, how would these francs be dispersed amongst the players? Because there's enough there to know that most likely Fermé was going to win, that the odds were kind of in his favor. But being that he didn't win, he shouldn't get the entire prize. So this was something that Chevalier brought up to Pascal and Fermé at the time, and they kind of discussed in these letters. Now, my logic originally, when tackling with this issue, was that I thought that they should, what came naturally to me was finding the percentage of flips won this far into the game out of how many flips they had, and then divide the winnings accordingly. So by my logic, that isn't using probability, it's just using what has already happened in the game. Fermé, who won 8 out of the 15 total flips, would be getting 53.33 francs, whereas Pascal, who won 7 out of the 15, would only be getting 46.67 francs. We'll talk about why my logic is a little bit more flawed than using probability at the end. But turning to what Fermé and Pascal discovered is that what we should be doing is, with the results, we should find all the potential flips left and categorize how many possibilities each player has to win. In doing so, we would be determining the probability of each player's success, then being able to realize who would be winning the money, and then from there, dividing the money via probability. So what this kind of looks like is, with the same situation set up where Pascal has 8 flips and Fermé has, or Pascal has 7 flips and Fermé has 8 flips, we can find out that 4 flips are left until there is a guaranteed winner. A guaranteed winner could happen in 3 flips, 2 flips, but with 4 flips, there would guaranteed be a winner. So from that, we'd be able to find out that there are actually 16 possibilities left for which way this game could go. And just kind of how we did when we were going through chapter 2 and learning about the probability and statistics of it all, I wrote out all of the possibilities left of those last 4 flips, and all 16 of them. And then I went ahead and highlighted the ones in which Pascal would win. Pascal in this situation being tails, could be flipped the other way. But from this, we can see that out of the 16 possibilities left, only 5 of the possibilities left Pascal with victory, which means that 11 out of 16 would be for Fermé, then resulting in 68.75% probability that Fermé would be winning the game versus 31.25% of Pascal, which out of 100 francs results in Fermé winning 68.75 francs and Pascal with 31.25 francs. You can kind of see that this is quite different from my logic. And where this kind of comes from is that my logic is from whatever has happened in the game thus far, versus probability being the probability of winning the game as a whole, which obviously are 2 very separate things that was really hard for me to kind of get over in the beginning of grappling with this kind of problem that is a little tricky, especially when dealing with francs at the time. But from this also, it can only be dramatized. This coin flip was only 1 coin flip away at the beginning of our scenario. Whereas if it was even earlier in the game, with less flips, there would be even less of kind of concrete flips and who won each flip to determine how much money goes where. Whereas probability, there will always kind of be an evolving probability of who's going to win the game each time that they reach the same number, whether that be 4 flips of them each winning, 5 flips of them each winning, kind of brings that probability back to 50%. So it gives us a better gauge at who is heading towards victory. And then if the game has to abruptly stop, how we kind of divide what is being waged. So, although in this situation, maybe Pascal is thinking that my logic might have been better for him because he'd get a little bit more francs from that, using probability in this way is a lot more accurate to figure out kind of the probability of gambling and winning, and then what we should do if we can't see it all the way through.